So we just looked at what to do if we want to take an integral of odd powers of sine and cosine. Now let's look at what we should do if we want to take an integral of an even power of sine and cosine. So the idea for this is we're going to use one of two formulas. So if we end up having a sine squared of some variable, that's going to equal 1 minus cosine of 2x over 2. If I end up having a cosine squared, then I'm going to rewrite that as 1 plus cosine of 2x all over 2. And I'll derive these formulas in a second. The reason I use these, or how I do this, is basically I just use the above formulas until all sines and cosines have odd powers. Now in the examples I'm going to show, I'll show 3 of them in this video. They all go down to a power of 1, and then I can take the antiderivative. But if I did something that got down to a power of 3, then I would use the same rule that we saw in the last video. So I guess before we go on, why are these true? Well, these are based on the double angle formula for cosine of 2x, which is going to equal cosine squared x minus sine squared x. If I want to solve for sine squared, I'm going to rewrite this cosine as 1 minus sine squared x. I have another minus sine squared x. That will equal cosine of 2x. I'll subtract 1 and combine like terms, so I get cosine of 2x minus 1 equals negative 2 sine squared x. And if I divide both sides by negative 2, I'll get sine squared x equals, and divided by the negative 2, change this cosine minus 1 to positive 1 minus cosine of 2x all over 2. And that's for sine. If I want to solve for cosine squared, I do pretty much the same thing. Use cosine of 2x equals cosine squared x minus sine squared x, the double angle formula for cosine. And instead I'm going to rewrite the sine squared as 1 minus cosine squared x. And, sorry, that should be a 2x. And in here, the minus distributes, and so I get a minus 1. And I get a plus cosine squared x, which gives me 2 cosine squared x equals this cosine of 2x. I'm going to add 1 and divide by 2, which would give me cosine squared x equals 1 plus cosine 2x, all divided by 2. So that's the quick derivation of these two formulas, and as long as I know these two formulas, I can break down even powers of sine and cosine. So let's look at one example. How am I going to take the antiderivative of sine squared? Well, I don't have a formula for sine squared. There's no chain rule here. I can't bring the 2 out. But what I can do is this. I know that sine squared is equal to 1 minus cosine 2 alpha over 2. So let me put that down. 1 minus cosine of 2 alpha over 2. So I can rewrite it this way. Now, this is the only time in this video that I'm going to write them out like this here. I prefer looking at it like this, as 1/2 minus cosine of 2 alpha over 2, because I'm going to have to take the antiderivative, and this is really easy to take the antiderivative of. I'd get the antiderivative of 1/2 d alpha is 1/2 alpha, or alpha over 2. The antiderivative of negative cosine 2 alpha over 2, well, it does not change signs. The antiderivative of negative cosine is negative sine. And either using a, well, I'll write it down here. So that's going to end up being over 4. Either I can do u substitution, or I can use the rule that I have a function of a constant times alpha. And so I'll explain why here. So we have the antiderivative of cosine of 2 alpha over 2 d alpha. And I can take the 1/2 out. Cosine of 2 alpha d alpha. And if I were taking the derivative, I would get a 2 times negative sine of 2 alpha. Since I'm taking the antiderivative, I'm going to have 1/2, or let's say sine of 2 alpha over 2, because if I were to take the derivative of this, the 2 that comes out would cancel out with this 2 down here, and I'd be left with cosine. So the antiderivative of cosine of 2 alpha is sine of 2 alpha over 2, because the derivative of sine of 2 alpha over 2 is cosine of 2 alpha. And in here I have sine of 2 alpha over 2 times 1/2, which gives me this over 4. Alright. Now what happens if I have more than 1 squared? Now notice they're both even powers. If either one of these were odd powers, I'd just use the odd power rule. It's easier. But since both are even powers, I'll split up both of them. So I know I can rewrite cosine squared of beta as 1/2 plus cosine of 2 beta over 2. I can rewrite sine squared of beta as 1/2 minus cosine of 2 beta over 2 d beta. And now I have the difference of squares rule. So I have a plus b times a minus b. We know that formula. A plus b times a minus b is a squared minus b squared. So I'll use that here. 1/2 times 1/2 is 1/4. If I tried to FOIL, this times negative that, plus that times this would cancel out, and I am left with the other term, which is cosine of 2 beta over 2 times negative cosine of 2 beta over 2, which is negative cosine squared of 2 beta over 4 d beta. But unfortunately, I still have a cosine squared, so I have to continue. So I will take the integral of 1/4. I'll take the negative 1/4 out of here, and then just deal with the cosine squared of 2 beta. And if I recall, the formula for cosine squared was 1 plus cosine 2x. But in this case, I have a 2 beta here. Let me get to write on here. I have a 2 beta here, which means this 2x is now going to be 2 times 2 beta, which would give me a 4 beta in there. So let's jump back to this. So I have 1 over 2 plus cosine of 4 beta, 2 times the 2 beta, over 2. D beta. And now I just need to finish it off. So I'll do some work here and I'll finish it up in that area. So integral, I have the 1/4, and then I'll distribute this through and get a minus 1/8 minus cosine of 4 beta over 8 d beta. And I could take the antiderivative straight away here. However, I have some like terms to combine. In the future, I'll just combine them as we go. So in here, I'll have the integral of 1/4 minus 1/8 is 1/8, because 2/8 minus 1/8. And then I have minus cosine of 4 beta divided by 8 d beta, which will equal the antiderivative of 1/8 d beta is beta over 8. And then the antiderivative of negative cosine of 4 beta over 8 is negative sine of 4 beta over, and I divide the over 8 by the 4, and I get over 32. So that one's a little bit more involved than the first one because I have cosine and sine both squared. So those two were indefinite integrals. Let's look at a definite integral. And this one is a cosine to the 4th. So two things going on here. So I'll rewrite the cosine to the 4th as cosine squared squared, so 0 to pi over 3 of cosine squared theta squared d theta. And I know that cosine squared is 1/2 plus cosine of 2 theta over 2 d theta. And now I will expand this out. 1/2 plus cosine 2 theta over 2 squared, either FOIL, Pascal's triangle, binomial theorem, however the heck you want to remember that. 0 to pi over 3 of, we have 1/2 squared, which is 1/4, plus 2 times 1/2 times cosine 2 theta over 2, which is going to end up being 2 cosine 2 theta over 4, which is cosine of 2 theta over 2, plus this squared, which is cosine squared 2 theta all over 4. And now you notice 1/4 is good, cosine of 2 theta over 2 is good, but cosine squared is bad, so I need to deal with this. And I will, like before, take the 1/4 out and deal with the cosine squared of 2 theta. Splitting up cosine squared of 2 theta is the same as doing 1/2 plus cosine of 4 theta over 2. And I'll bring down everything else. So we still have the integral from 0 to pi over 3 of 1/4 plus cosine of 2 theta over 2 plus this. And I'll save myself a little bit of time and I'll change some colors here. So I will distribute this through and get 1/8. So let me put this in, equals integral from 0 to pi over 3. 1/4, which is 2/8, plus 1/8 is 3/8. There is no like term with this cosine 2 theta because this is a cosine of 4 theta. So I have plus cosine of 2 theta over 2. And 1/4 times cosine of 4 theta over 2 is plus cosine of 4 theta over 8 d theta. I just noticed I forgot d theta there. Okay, and now I can take the antiderivative. So that's going to equal 3 theta over 8 plus antiderivative of cosine 2 theta over 2 is sine of 2 theta. I divide by 2, so I get over 4. Plus the antiderivative of cosine of 4 theta over 8 is sine of 4 theta. I divide by the 4, so I get over 32. And since this is a definite integral, I evaluate from 0 to pi over 3. And it's actually not too bad. So finishing it off, I put in the pi over 3. 3 over 8 times pi over 3 is 3 pi over 24. Okay, and I can reduce that. I will shortly. 2 times pi over 3 is 2 pi over 3. The sine of 2 pi over 3 is root 3 over 2. Four times pi over 3 is 4 pi over 3. The sine of 4 pi over 3 is going to be negative root 3 over 2. And thankfully, when I put in 0, 3/8 times 0 is 0. Sine of 2 times 0, which is sine of 0, is 0. Sine of 4 times 0, which is sine of 0, is 0. So that doesn't make a difference. And now, 3 pi over 24 is equal to pi over 8. Root 3 over 2 divided by 4 is root 3 over 8. Negative root 3 over 2 divided by 32 is negative root 3 over 64. And I can get a common denominator between these root 3's by multiplying this by 8 over 8, and I get 8 root 3 over 64. And finally, I'll get the pi over 8, that comes straight down. 8 root 3 over 64 minus 1 root 3 over 64 is plus 7 root 3 all over 64. Okay, comment below with questions if you have any, and I hope this helped out.